So we're in a heavy JK. We're going up a grade. You can see our tire pressure is low. We're on 40s. We got all sorts of drag. We got light bars. We got bumpers, winches. We're lifted. This Jeep is black. Now we've been averaging well over 100 degrees here. And when you add this all together, that puts a lot of load in the cooling system. Remember, we only have about a 23 by 23 inch area to put a radiator in a JK. Yes, we can go thicker, but that can pose problems. Remember, we got to get air through the radiator to transfer that heat. I've worked on JKs with 5-row radiators. I've pulled them out and put in 2-row radiators, and they've actually cooled better. When it comes to core design, there's a lot of options. You can get a 1-inch tube. You get 2 of those. Basically, you have a 2-inch core or a 52 millimeter. Using 2 1-inch tubes seems to work pretty good. The fin count is also important, meaning if you have a high efficiency core and the fins are really close together, that's going to reduce the restriction. Now, if you're running a tractor where the radiator is mounted externally and you have very powerful fans, that will work. But if you're running it in a JK where you have grill obstructions, you have air being deflected over the grill by a winch and a bumper, you have high pressure in the engine compartment, so we're trying to pull low pressure into a high pressure zone. We're trying to suck through a transmission cooler. We're trying to suck through an AC condenser that's hot because we got the air conditioning on. Then even with a powerful fan, you can have issues getting enough airflow through that radiator to cool the engine. So all these things have to come into account. Some guys are just unrealistic, expecting their JKs to cool at 10, 12,000 feet. And altitude is very important because remember, the air is thinner up there. There's not as much air for the fan to pull through the core. So if you're in 40s that are aired down to 20 psi, you got your grill blocked. Just by removing the grill mesh that was blocking the grill openings in this Jeep, we dropped close to 10 degrees in coolant temperature. Remember, there's a bubble that forms right in front of the grill, a small high pressure zone, if it's not designed properly. And then that forces the air up over the hood and you're reliant on the fan. The early JK fans pulled 2,000 to 2,500 CFM. They were 2-speed, brushed, in-runner designed DC motors. What that basically means is they were discrete fans. They were on and off. They didn't have a whole lot of power because they were brushed. The way Jeep achieved 2 speeds is using a voltage divider, or as some guys would call it, the fan resistor. So it drops the voltage down, system voltage down to about 8 volts, and that gives you your low speed. High speed uses full system voltage. Remember, in a DC brush motor, by increasing the voltage, you increase the speed. The Camaro fan and the Pentastar fan do not operate in that fashion. The Camaro SS fan and the Pentastar fan are pulse width modulated variable speed fans. They're outrunner designs, which means the outside of the can of the motor turns. This gives us more torque. We're running a 19-inch blade on the PWM fan, and we're running a 17-inch blade on the in-runner DC brushed motor design. So the PWM fans are pulling a lot more airflow, well over 3,000 CFM, and that's great. But here's the thing, I'm cruising along right now at 70 miles an hour. Because most of the air is being deflected over this grill, I'm running off that fan. If we were looking at fan percentage commanded, as we remove grill obstructions on the highway, you would see that fan command come down. You'd see it go from 70% to 60% to 50%. And ultimately, we would like to run purely off the airflow coming into the vehicle. And that's how a lot of vehicles work for a long time. The cooling fans would just turn off on the highway because you were running off the airflow. But in a JK, it's a little bit different. The JK has a small engine compartment. If you look at a Pentastar engine especially, it's a really large engine. And when you put the engine covers on it, it pretty much fills up the engine compartment. So we're pulling air into this engine compartment with a powerful fan. We're sucking air through a radiator core, through a hot AC condenser, through a transmission cooler, through screen mesh that's blocking a grill opening. And some grill openings are reduced when you go to the Angry Eye grills or some of the other aftermarket grills. Then we got a winch deflecting the air over the hood, so we have very little airflow ramming into the grill opening. So we're trying to pull this low pressure air from outside of the grill and suck it into the high pressure zone under the hood. And then it's got to get out of the engine compartment. Now the JK has a small engine compartment, so whether you got a Pentastar or a V8 Hemi or an LS, we want airflow through that engine compartment. Sometimes when cooling is very challenged, we'll run in an evacuation mode, which means we'll run the fan all the time at a low speed, and what that does, it helps push the hot air out of the engine compartment, which makes it easier for the fan to pull cool air in. Now it's not easy to pull cool air in because we got to go through all those obstructions, but here's the point. We want to get the air into the grill as freely as we can. We don't want that fan to have to work and fight to get that air into the grill. And a lot of guys just don't realize when you're putting KC daylighters or LED bars, winches that aren't sunk, mesh in your grill openings, you're making that fan work an awful lot harder. And at some point it may not have enough. If you go up to altitude, This particular Jeep was up at Moab, 7, 8, 9,000 feet. Air was really thin. Grill was blocked. Winch isn't sunk. And there's another side to this Jeep. This Jeep is also black, so on a clear sunny day like today, it's going to get hotter. I've actually measured the underhood temps in black JKs at 300 degrees plus. I've seen the plastic under the hood start to melt. So I'm not going to compare that to a stock Jeep with 29 or 30-inch tires that's a light color and has no grille obstructions, because that Jeep is just not going to have the same challenge. I want to talk a little bit about fan strategy. As you can see, we have our air conditioning on. It's over 100 degrees out. There's not a cloud in the sky, which means the sun's beating down on us. You can see that we're running at about 222 degrees. In the old days, I used to like to run 100 degrees over ambient. So if ambient was 100, I'd like to run at 200. In today's world, engines run a little bit warmer. These LSs and LTs like to run 210, 215, 220, 230. No problem at all. In fact, 240 is acceptable. 245 is acceptable. GM considers overheat at 255, and you go into a hot protection mode at 265. I got guys calling me up and freaking out that they're running at 212. What do I do? You don't do anything, because that's exactly where you should be running. What you don't want to do is install a 160 or 180 degree thermostat in one of these LSs and LTs and then wire your fan on high all the time. While that might be great for performance, it's not great for emissions and economy and longevity. When you run an engine too cool, condensation can be built up inside the crankcase, and that can corrode and cause other issues. You don't have the thermal efficiency that these engines are designed for. So don't run the engine too cool. Anywhere from 205 to 235 is perfectly normal. We're running at 224 right now. I'm very happy with that. It's a hot day. This Jeep is heavy. The tires are aired down. We got 13.5-inch wide 40s, so there's a lot of drag there. We got light bars. We got all sorts of stuff hanging out. We got steel armor. So let's talk about that fan strategy again. Some of you run your fans wide open all the time. In fact, this was the norm on Penn-Star fans and Hemis and some other builds. One, it wastes electrical energy. Two, it's annoying, and it can make it difficult to talk inside the vehicle with the windows down. Modulating the fan really is the way to go. If running in evacuation mode like we talked about earlier to keep the engine compartment cool, I'm all for that, and we can do that in these PWM fans. We can set them at 10 or 15%. You can barely hear them, if at all, and they keep that air moving through the engine compartment, and they keep the engine coolant temp more stable. In the early J case, we programmed low speed to come on at about 210 degrees. We had what was called a hysteresis. Hysteresis is how many degrees it drops before it turns off. So it would turn on at about 210, and it would turn off at about 202. High speed would turn on at about 217. So what we had was this fan that would turn on and off. It would be at 0 speed, providing no cooling. The engine would warm up pretty quick, and then it would discreetly turn on, and you would see that temp drop pretty rapidly because it was running pretty hard. So what you would have is this cycle, up and down, up and down. With a variable speed fan, you don't get that cycle. It's a smooth linear coolant temperature. Since the variable speed fan doesn't shut off and let that heat build up under the hood, I do feel that they tend to run cooler because there's a continuous evacuation of hot air out the engine compartment. A lot of my customers ask, do I need a cold air hood? Getting air out of the engine compartment is just as critical as getting cool air into the engine compartment. So the answer is yes and no. If you properly design your cooling system and you have stock fender liners and you don't have skid plate, the answer is probably no. You don't need a cold air hood. But here's the problem. A lot of guys will put in full skid plates, so that heat has no place to go underneath. It's trapped. Then they put in these fender liners that are solid. That traps in the air. You've captured the air filter, so intake air temps can reach 200 degrees plus. In that situation, a cold air hood is beneficial. Now, a cold air hood's not going to hurt you at all. Go ahead and put one on if you want. I do advise against getting some of these cold air hoods that have openings in stupid places, like right above the accessory belt drive or right above the engine exhaust. Get one that's designed properly, so when there's snow or ice, you don't have to worry about intrusion. When Chrysler redesigned the AEV cold air hood and sealed off the depression so that water wouldn't drip into the engine compartment, water would pool in that space. If it froze overnight and you took off, it had a chance of coming back and breaking your windshield. So there's a lot of different hood designs. Pick one out that works for you. Now, moving back to fan control. We know the fan has to cool the engine. What do we want to keep the engine at? Like I said, anywhere from 205 to 235 is perfectly normal. Do not freak out if you go over 220 degrees. These engines are designed for that. And there's no reason to be screaming the fan to try to keep it down at 200 degrees. We just don't need to do that. So in our LS and LTs, GM starts bringing the fan in in the high teens, and they really start winding it up in the 230. And that's where we do it. And we keep it exactly the same as GM. It works just fine. Now remember, this is just based on coolant temp. The way the air conditioning system works is the compressor compresses air, it runs it through an orifice or an expansion valve, or whatever the design of the system is. It expands that gas, that freon, which cools that gas down in the evaporator, and then a blower fan blows that into the cab. And that's great. The inherent design of the AC system, though, in order to have cool air being blown through the evaporator, that hot air has to go somewhere, and that goes through the condenser. So the condenser has to have that hot air moved out. Pretty much temperature and pressure are correlated 1-to-1. So if your condenser is at 200 psi, it's at 200 degrees. On a hot day like today, it can easily exceed 300 degrees. So now we're taking that hot air from the condenser and we're pushing it into the radiator. As the fan pulls the air through the radiator, the low pressure in front of the radiator now sucks that hot air from the condenser into the radiator. We've now transferred that heat. So the fan is programmed for AC pressure and coolant temperature. And what I find is basically it's whichever is greater. So if the AC pressure overrides the engine coolant temp, so the fan is going to run to provide what the AC pressure needs. We don't need to run the AC pressure at 180 psi all the time. On a hot day like today, the fan would be screaming. Now again, the cooling air coming into that grill will cool that AC condenser and reduce the load on the fan. A lot of guys don't know when you're going down the road and your engine's running cool, you're, oh look, everything's great. The airflow coming in the grill is cooling the engine and the AC. It's not. What's cooling your engine and AC is the cooling fan, because your grill is blocked. If you've got the screen mesh and the winch that's not sunk and all that. And I know I keep harping on that, and that might get annoying, but I can't tell you how many Jeeps come into my shop. And I'm not just talking about LSs and LTs. I'm talking about Penstars, 3.8s, Hemis. I just had a Hemi in the shop with grill inserts, a reduced inlet size grill. It was a black Rubicon. Like I said, it was a Hemi, and it was running 240 to 260 degrees. Couldn't get any cold air into the grill. We ended up having to fit a variable speed fan to it and our fan controller to get this thing to run cool. We had to move some lights around. The customer's going to sync the winch. This is really important stuff in the summertime. So my point is when you're cruising down the highway, don't think that that airflow is cooling your engine. It may not. You might be reliant on that fan. Look at your fan percentage commanded. And if it's up there 60, 70, 80%, that fan is honking, and that fan is using energy, and that fan is getting hot. Just by removing those obstructions, you're going to see that fan percentage come down and down and down. I like to see that fan at 10, 15, 20% with the air conditioning on, which tells me we're running off airflow and not the fan. So the AC condenser is a critical part of the cooling system because it's putting hot air into the radiator. And if you look at some of these long grades like the Baker grade out in California and a lot of the grades in Colorado and Utah, they tell you to turn the air conditioning off going up the grade. That's so that that hot air from the AC condenser doesn't get into your radiator and reduce cooling system performance. Now in front of the AC condenser, we're invariably going to have a transmission cooler because that's where it belongs. It does not belong in the bottom of the AC condenser. It's on the 3.8 Wranglers. That system was a failure. It didn't cool the transmission on modded JKs and sometimes on stock JKs well enough because that transmission cooler was behind the bumper and didn't get proper airflow. Yes, it did get some airflow from the fan, but the 3.8 fan wasn't the most powerful fan out. The transmission fluid would get really hot under long grades. It would expand. It would push vaporized transmission fluid out the dipstick tube onto the exhaust manifold, and poof, you had a fire and a lot of JKs burned. So Mopar came out with a retrofit transmission cooler. Chrysler did a software update to give you the ding 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 hot oil on the dash to warn you to stop. But when the Pentastar JK came out with the automatic, they did it properly. They put a transmission cooler in front of the AC condenser. So now in front of the radiator we have an AC condenser that's putting hot air into the radiator. And in front of the AC condenser we have a transmission cooler that's putting hot air into the AC condenser, which is then putting hot air into the radiator. So you can see this domino effect. And the fan has to suck through all three of these to get cooling air for the engine. Maybe now it's becoming clearer why it's so important to have cool air going into the grill, because cool air being forced into the grill will aid your pushing and pulling air now, rather than depending the cooling fan to essentially suck through a straw. So I can tell you this JK was running warmer, and just by removing the screen mesh that was blocking the grill openings, you can see our temps have come down. In fact, we're almost 100 degrees above ambient right now, which is right about the ideal. I find it ironic that Jeep sells screen mesh to put in your grill openings when in all the technical manuals, if you go to Tech Authority, Mitchell, the first thing Jeep says about cooling systems is keep those grill openings unobstructed. Do not block them with anything. This vehicle does have skid plates. If you're going to do full skid plates, do a couple of things. One, wrap the exhaust with heat tape. Second, make some cooling slots or cooling openings in your skids. It's not going to affect the performance of the skids. In the earlier JKs, I think it was 7, 8, and 9, used skid plates. And what they found was debris would come up on top of that skid plate, and because they heated the exhaust, it would catch on fire. Papers and things, plastic bags would catch on fire. So Jeep redesigned the skid plates and went to a more skeletonized skid plate. Fender liners can be another sore point. I've seen these fender liners that are beautifully made stamped aluminum, and they pretty much seal the gap between the frame and the body, and there's no place for the air to go. Get the fender liners that have screen built into them so the air can flow through them. The fender liners that have the louvers built into them. On this grade, on a hot day like today, a stock JK with 37s to 40s will run 230 to 240, 245 degrees, I find. Let's see how this JK does. We got a high compression 6.2 LS in this. If this is a 5.3 or 6.0 with lower compression, it wouldn't put as much load on the system. And we're going to talk about something, and I might lose a couple of you on this discussion because this is something that's not well understood and something that took us a long time to figure out. Fan strategy when it comes to the PWM fans. So basically a pulse width modulated fan is a pretty simple device to hook up. You got power, you got ground, and you got a signal wire. That signal wire works at a certain frequency. The frequency is different depending on the fan you're running. Like a Camaro is different than a Pentastar, and a Pentastar can be different than a Corvette. The Corvette, for example, is about 128 hertz. The Pentastar is about 10 hertz. So we have the basic PWM frequency. So all we got to do is change this signal to drive the fan. We can drive it to anything we want. Now the fan essentially has 0 to 100%. And you say, oh, well, why don't you just run it 0 to 100%? Well, you can, and this is the problem. And I'm going to try to explain this to the best of my ability, but we've run into a lot of problems where guys will take these fans, and not just in our swaps, but in hot rods, and they will slave engine coolant temp to 100%, which basically means, oh, when it hits 230 degrees, the fan's wide open at 100%. All you're going to do is turn that fan off and overheat your engine. And here's how it worked. At least here's how we have backwards engineered and figured out how this works. First, let's put this thing under a load. We got the air conditioning on. We're at 222 degrees. We're going to accelerate out to 65 miles an hour, which is our speed limit. We're going to set cruise. And what we're going to see is that fan temp coming up. We're actually going to go back into tap shift to hold this gear. So you're going to see we're holding in 5th gear right now. Now remember, these tires are aired down, air conditioning blasting, a lot of drag. We're going up this hill. We're over 3,000 feet, probably about 4,500 feet at the top of the hill. Now I'm going to expect to see that coolant temp go up because GM doesn't really wind the fan up till the high 220s, low 230s. So getting back to our discussion on the fan driver, you have to limit how much drive you put on the engine coolant temp. You might only be at 65, 70, 75%. And you say, well, that's not enough. But here's the problem. When the intake air temp hits 200 degrees, when the transmission hits 200 degrees, when the AC pressure hits 350, that fan needs to wind up. Those other parameters are what's called riders. Riders add on to the engine coolant temp. So it's simple addition. You keep adding percentage. Now I'm actually surprised we're staying at 226 right now, because this is a pretty steep grade. It's a pretty hot day. Stock JKs I drive up here running the 230s to 240s, but we'll be coming up. We'll be coming up in the 230s here real soon. So these riders add to the engine coolant temp. Now here's the critical part you need to listen to. If you overdrive a pulse width modulated fan, and it doesn't matter if it's a Pentastar fan or a Camaro fan, you're going to drive it into what's called a diagnostic mode. And at that point, the fan's going to slow down. Once it reaches over 90%, 91%, that fan's going to start winding down. And then you get what's called runaway. The coolant temp's going to run away because it's going to get hotter, and the hotter it gets, the more it's going to drive the fan. The further it's going to go into the diagnostic mode, the further the fan's going to slow down. And before you know it, you're at 265 degrees. So the trick is to get as much fan operation as we can get without running into the diagnostic mode. So we have to limit those riders. We have to limit the engine coolant temp. So when everything is added together, coolant temp, air intake temp, vehicle speed, AC condenser pressure, transmission temperature, when they're all added up, they cannot get into that diagnostic region. If it does, you're going to be in trouble. This is why it's so important to get cooling air coming in the grill, because cooling air coming into the grill will supplement the fan, bring that percentage commanded down. So we had to slow down because of construction, but we peaked at 231.8 degrees, which in my opinion is excellent in this heavy JK on a hot day. So getting back to the discussion, when you add up all these riders on top of engine coolant temperature, things like transmission temperature, air intake temperature, vehicle speed, AC condenser pressure, if they add up to more than the fan is capable of putting out, that fan is going to start shutting down. A A lot of you have heard of duty cycle, like on a welder, let's say. You have a 200 amp welder and it can run 100% duty cycle at 50 amps, which means you can run continuously at 50 amps. But if you go up to 200 amps, it might have a 30% duty cycle, which means you can only run 30% of the time. So 3 out of 10 minutes, or otherwise you're going to overload that welder. It's the same thing with this cooling fan. This cooling fan has to protect itself. It's a module. It's not just a DC brush motor. So when you drive it into the diagnostic zone, that fan's going to start shutting down. Now, I get Jeeps that are built where aftermarket tuners, I don't know if you can hear that Camaro SS fan, but it's probably about 60-70% right now, maybe 80. And you can see that temp's coming down pretty quick. So what happens is tuners get a hold of these vehicles and they think this is like the old days, and they just crank up the engine coolant temp signal or percentage to 100%. What they don't realize they're doing is they are overdriving this fan. The fan slows down, you overheat, and then the first thing you say is, well, the cooling system's not big enough, there's a problem. Never understanding what they did. You can see how fast this Camaro SS fan can bring the temps down. And notice that our intake temp is about 150 degrees. And you say, well, that's really high. But it's really not in a black JK like this under the loader. Just put it under. There is no cold air intake on this Jeep. Now, you could add a cold air intake. That'll help. But really what I want to make a point of right now is driving the pulse width modulated fans. Tuners get a hold of these. They drive that fan up, not realizing when the riders kick in, they're going to put that fan into a diagnostic mode. That fan's going to slow down and you're going to overheat. So we learned this through the School of Hard Knocks. And when aftermarket tuners get into our tunes and try to get more performance, please tell them don't mess with the tune that we supply for your fan. If they do, there's a chance you're going to have a problem. Now, you're probably not going to have a problem if you're in Florida or LA at sea level where the air is really thick and ambient temps aren't that hot. But if you're up in Utah at Moab, if you're up in California at the Rubicon, if you're up at Colorado in the Eisenhower Pass where the air is very thin, you've blocked your grill. You've got lights in front of your grill openings. You've got screen mesh in the grill openings. Then I can almost assure you you're going to have a problem. So tell the tuner, don't wind that fan up. This is not like the old days. In fact, almost every aspect of these new operating systems is getting more and more complex, and we're learning every day. The LT controllers have some very strange, if you're used to traditional tuning, behavior. Things like coolant temp. We now have target goals. We don't have a table like in the old days. They're coefficient-based strategies. So it's not like the old days where you just plug numbers in and then think, well, it's going to do it. To a certain degree, yes, that's true. But what you got to look at is what's in the background, and that's what the guys don't see. They blindly change a value thinking, oh, I'm going to drive this 10% more, not realizing how many other things that affects in the operating system. And on top of that, how many things in the operating system affect that table. And that's why you can easily overdrive these fans and push yourself into a diagnostic mode and shut the fan down. The 2 points I really want to get across in this video are, do not block your grill. Don't run a reduced size grill opening. Do not run screen mesh. Sync your winch. Do not run lights, light bars, stingers, and anything else that's going to inhibit air at high speed. Remember, even a 2 or 3 inch stinger sticking a few feet in front of your grill can deflect the majority of the air going into the grill. I had a guy run Baja with an LS3, and he had a 3-inch diameter stinger sticking about 3 feet out in front of his grill, right in the middle of the grill. He said everything was great up to about 70, 80 miles an hour, but at 100 miles an hour, it would start to overheat. So I told him to tape on some deflectors to try to keep that air going into the grill, and he did, and it helped tremendously. All right, guys, let's take a look. It's a hot day, not a cloud in the sky. You can see the haze over Vegas, which is trapping the hot air in. Remember that back in the LA basin. Here's the Rubicon we're driving. Now look at this. You're at 10,000 feet in a Rubicon on 40s with 13.5-inch tires. You got a winch that's not sunk. You've got a stinger in front of that. You got this grill mesh in the grill openings. Now, just by removing this grill mesh, you can see how much airflow we're opening up. And like I said, we dropped about 10 degrees in temperature on the highway just by removing this grill mesh. Now, sinking this winch is going to be huge. If you sink this winch, we're going to end up putting air into this grill, which is going to assist the fan. Now, you can hear that fan winding up and slowing down. The air conditioning is on, the engine is running, it's checking the intake air temp, transmission temp, so you can hear it speeding up and slowing down based on need. The vehicle is not moving, so there's no airflow going into the grill. However, when we do get moving, what you'll notice is that fan's going to slow down. When a grill is properly designed and air is going into it, I can actually watch that command go down as I get on the highway. I'll go from 60% to 50% to 40%, and in some cases I'll see the fan shut off. In the case of this Jeep, the faster I go, the higher the fan command would get. 60%, 70%, 80%. And remember, when you add the air intake temp, the transmission temp, from turning these larger tires, you're going to end up overdriving that fan. If the tune is not correct, your fan's going to start slowing down and you're going to be stuck on the side of the road. This Jeep has some really nice armor. This is the metal cloak armor. This is what I have in my Jeep. These fenders come off. Now you will notice that these fender liners are not allowing a lot of air out. This is, again, not something that you want to do. While these do protect mud from getting in, I would definitely ventilate these fender liners. So let's look at some of the data I monitor on these test drives. Notice on the top our coolant temp is at 197. That's almost on the thermostat. The reason that is because the air conditioning pressure, if you see below it to the right, is over 200 psi. So the fan is winding up to control AC pressure, and it's cooling down the engine at the same time. So the engine's pretty much running on the thermostat. I got knock retard on here because that's important, as you all know. Our air intake temp is at 140, which is pretty good for such a hot day. Trans fluid temp is coming and going. On some of these apps that are Bluetooth, it can't get all the data at the same time off the bus. So what you'll see is that temperature comes and goes. And it's been averaging about 175 to 180, which is actually really good. I like to see it under 200 and obviously less than that if possible. So let's hang out a second until it comes back. There it goes. So we're at 179. That's good. If you notice that your trans temps are averaging over 200 all the time, get a bigger transmission cooler. And guys, it is a really hot day out today. So those are pretty good values for a Jeep like this. Now we're going to run it up this trail, which is about a 6-degree grade, and it's over 100 degrees out, and we'll see what these values are at the end. Alright guys, we just came up this grade at a pretty good clip, as the video will show. Air conditioning on. We were at about 217 when I stopped. We're at 215 now, so that's really good. Intake temp's good. AC pressure's good. Let's wait to see what this transmission says. 206. So the trans temp's just over 200. That's a little warmer than I'd like to see it. We might upgrade the tranny cooler in this. I've got to look at it. But overall, those temps are pretty good for such a hot day. Okay, so we're leaving the mountain. As you can see, our temps coming down the mountain are just off the thermostat on the coolant temp. What I learned was the fan is not being overdriven, that the transmission probably needs to be cooled a little bit better. Now, guys, by removing the obstructions in front of the transmission cooler, like the winch that's not sunk, the grill mesh which we moved, stingers, that's going to increase the efficiency of the transmission cooler. But if we're stuck with what we got, then we're going to have to go to a bigger transmission cooler. We're going to talk more about cooling systems, because cooling these heavy JKs with V8s, high compression V8s, on these hot days can be challenging. And we've seen this for 10 years, and we've got some experience with what works and what doesn't. So stay tuned.